All right, guys, y'all ready? It's pretty basic. So we've already done LRAM, we've already done RRAM, we've already done MRAM, we've also done lower, we've also done upper. So what is trapezoid? Well, trapezoidal rule, here it is. It's this one here, essentially. You're going to use this when you have equal heights. The heights are determined by your delta x. I guess first let's talk about what a trapezoid is and what you guys are going to see. So here's how you guys recognize a normal trapezoid. Let's see. That's how you saw it in geometry, where these are your bases, base 1, base 2, and that's your height. And then the area of a trapezoid, area. Base 1 plus base 2 times height divided by 2. You guys remember that? Okay, we are going to see our trapezoids like this. It's the same. This is still our height. This is still our height. This is our base. Base 1, base 2, and it's still the same formula. It's still this. We're still okay? So when we do our trapezoids, so look, check it out, guys. I'm going to draw just a random curve. And I'm going to put 4 trapezoids. So let me put my trapezoid here. Point. That one. Let me exaggerate it so we can see the trapezoids better. Point here, point there, point here, point here. All right, so here are trapezoids. Point on the curve, connect. Point on the curve, connect. Point on the curve, connect. You guys see those trapezoids? N equals 1, N equals 2, N equals 3. And let me put one more. N equals 4. 4 trapezoids in there. If I call this, I guess that says why not. You can pronounce it y0. So I guess I'm going to call this vertical distance here y0, y1, y2, y3, y4. If you have 4 trapezoids, you need 5 points. All I'm going to do is calculate the area of those trapezoids, just utilizing that formula. Base 1 plus base 2 times height divided by 2. Notice that your height is just your delta x. So the delta x is your height. Cool? Okay, here you go. I'm just calculating the area of the first trapezoid. Area equals. I'm going to go parenthesis, y naught plus y1, close it. I'm going to multiply by the height. I'm going to divide it by 2. Chav, what's the height? I don't know, whatever this is. That's your height. They all have equal delta x's. Chav, what are you doing? I'm just trying to get to this. I'm trying to get to that formula so you can see that it comes from somewhere. Plus y1 plus y2 times height divided by 2. Plus y2 plus y3 times height divided by 2. Plus y3 plus y4 times height divided by 2. There it is. I have 4 trapezoids. I have 4 little, I guess, what do you want to call them? Terms. Are we still all right? Okay. So check it out. You see how each one of these quote-unquote terms has an h over 2? I can what with those? Yep. So I have area equals h over 2, parenthesis, y naught plus y1 plus y1. All I'm doing is just adding them up. Plus y2 plus y2 plus y3 plus y3 plus y4. Close. All I did was just drop the parentheses and write it all out. Are we still all right? How many y1s do you see? How many y2s do you see? How many y3s do you see? So my formula, as long as your delta x's are all the same, you can use this formula. H over 2 parenthesis y naught plus 2y1 plus 2y2 plus 2y3 plus y4. Where the only y's that don't have a coefficient of 2 in the front are your endpoints. Endpoints don't have 2 as a coefficient. Do we notice that, guys? All right. So just in case you're asking, what is that n minus 1? That's second to the last term. And then, of course, the nth term is the last term. So the first term and the last term, that's your first. This is your last. Don't have a 2 in the front. You can only use this formula if your heights, which is your delta x, are all the same. Remember that, guys. Matter of fact, we're going to be pushing for you to not even use the formula. I just want, every year it happens that there's a student that, I want to use the formula, and so that's the only reason why I'm bringing this formula up. I prefer that you don't even use it. You just go one at a time. Are we still okay, guys? All right. And okay, Chav, what about this right here? It says that it's the same thing as doing LRAM plus RRAM divided by 2. Well, yeah, it is. Because if you notice, look at the subinterval, the leftmost point and the rightmost point. So do you guys see how it's the same? How leftmost point plus rightmost point divided by 2? You're going to get, so yeah, that's because that's what it is. See, leftmost and rightmost, they're both on the curve. See, but it's better. It's just, I personally like that one better. Not necessarily the formula with the same delta x's, but doing each trapezoid one at a time. Cool or not cool? All right, let's keep going. So look what it says. Example 1. Use the trapezoid rule with how many trapezoids? 4, no Yanni. 4 traps. To estimate the integral from 1 to 2 of x squared dx, compare the estimate with the exact value. You guys ready? I'm going to exaggerate. Now you're going to make me want to yawn, miss. Now I kind of really want to yawn. It's your fault. All right. Notice where we start and notice where we stop. Are we still okay? So I'm going to say that 1 is like right here. And I'm going to say that 2 is like right here. How many trapezoids do I have again? So let me see. Boom. 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 1, 2, 3, 4. There we go. Ask me, miss. Ask me. Pregúntame. Oh. Sorry. All right, here we go. First one, put a point right at 1. By the way, delta x is 2 minus 1 divided by 4, so 1/4, which happens to be also your height. That's how you find the height of the trapezoid. So here's 1. That value right here is 1.25. This value right here is 1.5. This value right here is 1.75. I need all these points. Here we go. I'm going to connect them. Ready? I'm just going to connect them. You don't have to do sound effects. This is like n equals 1, n equals 2, n equals 3. Oh, I need one more. N equals 4. Are we still all right? All right, here we go. I'm finding the area of these trapezoids. Area equals. All I'm doing is this formula right here, guys. I guess I could use this one, but I guess I'm just going to use this formula right here. No, we're good. So the delta x is 1/4. So that's my height. So 1/4 divided by 2. So in a little bit, that's going to turn to 1/8. Open parenthesis. My y naught is this distance. This is your y naught right here. That's your first one. That's your y naught. All right, so here we go. I'm going to go, this is x squared. So I'm going to go 1 squared. Are we still okay? Times 2. Child, where did that 2 come from? I'm just using this formula. Here's the y1. This is the y1. This one right here. That's 1.25. 1.25 close it squared plus 2 times 1.5 close it squared. Yeah, that 2 is this 2. Should I use a different color? Yeah. Plus 2 times 1.75 close it squared. Now here we go. Here's my last term. Do I need to have a 2 in the front? No, because it's my last one, guys. Plus 2. It just so happens that it's a 2, but that's not the coefficient of 2. That's just this coordinate right here. 2. And then 2 squared will tell me what that y value is. Hey, stop. That's a demerit. There, close my parenthesis. Yes. From this value. It's leftmost. You know what I mean? Or are you just saying that? It says trapezoid. Trapezoid, you need the leftmost and the rightmost. See? Leftmost, rightmost. So you need the vertical displacements. Base 1 plus base 2 times height divided by 2. But the reason why there's 2, the reason why I'm using this formula, all my delta x's are the same. So I can just use this formula. You know what I mean? You sure? You're just saying that. Okay. All right, guys, take your calculator or take your phones. And I'm just going to go 1/8 times all that. So here we go. I'm going to take my calculator. I'm just going to go into y equals. And I'm just going to type in x squared. So know how to use your calculator, guys. Look, check it out. I'm going to go 1/8. And I'm going to open up a parenthesis. And I'm going to go alpha trace y1 evaluated at 1 plus 2 times alpha trace y1 evaluated at 1.25 plus 2 alpha trace y1 evaluated at 1.5 plus 2 alpha trace 1 evaluated at 1.75. And then the last one does not have a 2 in the front. So plus alpha trace y1 evaluated at 2, close, enter. And there it is. That's my answer, guys. Hey, stop yawning, guys. Area equals 2. Are you not entertained? 2.34375. 2.34375. All I did was this, guys. Now, in my morning period, some kids didn't understand. They were like, what are you talking about? I mean, I'm sure they did, but they were kind of like, Chop, I'm confused. Where's the square? Everyone knows that it's already embedded, right? It's okay. Do you guys want to see that, or you guys? Okay. All right. So just make sure that we already know that it's the same. Okay. Are we cool? All right. Here we go. Hold on. Before we go to the next, how do I find the exact area? Well, just use the calculator for now because you guys don't know fundamental theorem of calculus. Stop. I'm seeing you. All right. Here we go. Look. Math 9 from 1 to 2 of x squared. You don't know how to do antiderivative of top minus antiderivative of bottom. I guess technically you know, but you don't know because you haven't done it. We haven't done the proof yet. But look, there's the actual answer. Is that pretty close to the real deal? Yeah, 2.34375 is pretty close to 2.33333. Isn't that cool? Okay. Yeah. All right, here we go, guys. Before we begin, do you guys know how y equals 1/2 e to the x looks like? You don't know? Guys, it looks the same as y equals e to the x. The only difference is for the horizontal stretch. Well, I guess you can say vertical compression. Yeah. All right. Y equals e to the x looks like this. So y equals 1/2 e to the x looks the same, but with a vertical compression. On the interval, -2 to 4, if 3 equal subdivisions are used, what is the trapezoidal approximation of that? Earlier in the morning, we did this longhand. We did not use the formula. We just did this. We just did this longhand. We did this formula. But You know what? I think it's probably easier if we just use the formula because our delta x's are all the same. So here we go. My delta x, which happens to be my height of the trapezoid, is going to be upper minus lower, 4 minus negative 2, divided by, how many trapezoids do I want? 3. So 6 divided by 3, what do I get? That's the height of each one. Yay or nay? All right, let me give you a visual because you guys are visual. So here is how I look, more or less. It's not perfect. It's not perfect. I'm going to say here's negative 2, 0, 2, and I'm going to say here's 4. All right, here's my trapezoids. Let's do it in purple. Point, point. That's my first trapezoid, n equals 1. Here's my second trapezoid, n equals 2. And here's my third trapezoid, n equals 3. Y'all ready? Here we go. Area. Area of a trapezoid, I'm just using my formula, this one right here. So it says h divided by 2. Well, my height is 2. 2 divided by 2, open parenthesis. My why not? Well, the vertical displacement right here is just e to the negative 2 over 2. There's no 2 in the front. Plus, the next one, let's see, 2 in the front. I'm using my formula, guys. E to the 0 over 2 plus 2. I'm doing this one right here. E squared over 2 plus, this is my last one. Does my last one have a coefficient of 2 in the front? No. E to the 4th over 2. What's 2 divided by 2? 1. So this is just a 1. And then I see, what do I see? Let me see. E negative 2 over 2 plus e to the 0 plus e squared plus e to the 4 over 2. So let's look for this first. And I see that none of the answer choices have over 2 for the first two. So that means I'm going to factor out a half. If I factor out a half, here's what I get. E to the negative 2 plus, that's a 1 in front of that, that's a 1 in front of that. How many halves do I fit into 1? 2. So 2e to the 0 plus 2e squared plus e to the 4th. All right, I look for that. And I do have it. They just rewrote it weird. What's the answer? What's the answer, guys? D as in Darren or Deborah. How do we feel? Are we all right? Check it out. Check it out. The next one's going to be cool. Example 3, the function f is continuous on the closed interval 1 to 7 and has values that are given in the table below. Using the subintervals 1 to 4, so here are my partitions, 4 to 6 and 6 to 7. What is the trapezoidal approximation? All right, here we go, guys. Integral from 1 to 7 of f of x dx equals, so my delta x's are your heights, and the y value, the f of x's, are these that I'm circling are your bases. Circle, bases. That's not a 0. That's just to identify circles. Do you guys see that? All right. My first, so I'm gonna title it n equals 1, n equals 2, n equals 3. I have 3 trapezoids. Ready? Here's my n equals 1. So my first base is 10, plus the second base is 30, and I'm gonna multiply that sucker by your delta x. What's the difference between 4 and 1? 3. Does everyone know where that 3 came from? And that 3 came from 4 minus 1. I guess I'll put it here for good notes. That 3 is 4 minus 1. That's your delta x for the first trapezoid. This formula. That's your I can write a visual. So let me draw a visual real quick. This is not perfect. I'm just drawing one just to be quick. You know what I mean? Okay, look, 110. I'm going to say here's 1, not to scale, 10 points. And then 430, I'm going to say here's 4, and I'm going to say here's 30, point. And then look, your trapezoid is this. Remember, the trapezoid is on this side. So this is your base 1, this is your base 2. So 10 plus 30. And then the delta x is your delta x is your height, remember? So base 1 plus base 2 times your 3 divided by 2. Does everyone see how we got that? Okay. Yeah, let me know. Plus, that's the first. I still got more trapezoids. Plus, parenthesis, 30 plus what? 40 times, what's the delta x between 4 and 6? 2. That's your height. That's your delta x, guys. Delta x. I'll put it right here, which is your height. What was it? 6 minus 4. And then all this divided by 2. There it is. Plus, here comes my third trapezoid. 40 plus 20 times, what's the difference between 7 and 6? 1. All this divided by 2. Good job. Good job. And no one yawns. Good job. All right. What's 30 plus 10? 40 times 3 divided by 2 plus, these 2's cancel out. 40 plus 30 is 70 plus 40 plus 20 is 60 divided by 2. All right, well, let's see what this is. 40 divided by 2 is 20, and 20 times 3 is 60 plus 70 plus 30. 60 plus 70 is 130 plus another 30 is, there it is. Are we getting better at these? I did put an equal sign. Yeah. Yeah, I could have put equal signs there. Is this exciting stuff? Yeah, Miss Pam is super excited. Don't worry, Pam. All right, guys, leave some room in the bottom here. How much room do I need? Not much. Okay, so this is supposed to be like a quick review, and then LRAM, MRAM, and RRAM do not care about concavity. They care about whether the function is increasing or decreasing for determining overestimate and underestimate. Trapezoid does not care about increasing or decreasing. It cares about concavity. And we're going to see right now. So it says this, I guess put a bullet on all these. These are all different, different scenarios. And we'll put both scenarios in here. So look, if a function f of x is strictly increasing, underline that, from a to b, and you do an LRAM with equal subdivisions, LRAM will produce an underestimate. Well, let's see. I'm just doing a strictly increasing concave up, strictly increasing concave down. I'm going to put 3 rectangles for LRAM, and let's see if it does an underestimate. Boom. Okay, so far so good. Oh yeah, that's definitely, look how all 3 of my rectangles are under the curve. Let's see of the other one, the one that's concave down. Yep, look at that. All 3 are under the curve. So, check mark. It is an underestimate, no matter the concavity. As long as it's increasing and you do an LRAM, it's going to be a underestimate. Are we cool? All right, let's go to the next one. If the function f of x is strictly increasing, so I'm strictly increasing, and I'm going to do an RRAM. So again, same thing. I'm going to do an RRAM. So strictly increasing, concave up, strictly increasing, concave down. All right, let's see. Put three RRAMs. Oh yeah, look at that. Hell yeah. Look at that. They're all above the curve. Oh, what about this one, Chav? What about that one? We already know. Isn't that cool? So no matter what, if you're doing an RRAM with a strictly increasing function, it's going to be an overestimate. Do we care about concavity? No, it's going to be an overestimate no matter what. Let's go to the next one. Look, this one says strictly decreasing, and I'm doing LRAM. So I'm going to do strictly decreasing, concave up, and concave down. So here we go. Decreasing, concave up, decreasing, concave down. And let's see. It says RRAM. So RRAM. Yeah, look at that. Hold on. I did RRAM. I was supposed to do what? How come you guys didn't tell me? LRAM. Let's do LRAM. No wonder you guys were like, what? All right, there we go. I'm too fast for my own good. All right, I'm doing LRAM again on the next one. Okay, I didn't mess this one up this time, guys. Look at that. I did LRAM on both. This time I did LRAM on both. OMG, I'm still mad at myself for doing RRAM and saying, oh, look at that. But we fixed it. Are they both overestimates? Yes, they're both overestimates. LRAM does an overestimate if it's a strictly decreasing curve. Cool or not cool? Okay, let's go to the next one. Strictly decreasing again. So concave up and concave down. So here it is. Concave up. Leave some room, by the way. Leave some room. And concave down. Leave like half this room. Now I'm doing RRAM. So that's the one that I did last time there. All right, RRAM. Yep, look at that. RRAM. So RRAM does an underestimate for a strictly decreasing curve. Yay or nay? All right, cut it down the middle. Don't worry, we're almost done, guys. Cut it down the middle. Do an increasing curve concave up. And do an increasing curve concave down. And then let me make it better. And then do a decreasing curve concave up. And a decreasing curve concave down. I'm just going to do one trapezoid. So look, point right here. Point right here. That's for concave up. And look at the other concave up one. I'm going to go to the other concave up. Point, point. What do you notice about both concave up curves? Is it an underestimate or overestimate with trapezoid? It's an overestimate with concave up. Do you guys notice that? Regardless of whether I'm increasing or decreasing, so I'm going to put overestimate, overestimate, overestimate. And I'll change the other one to blue. Look, I'm just putting one trapezoid. One trapezoid. If you zoom in, is it going to be an overestimate or underestimate for concave down? Underestimate. I color coded it, guys. In conclusion, before we move on, guys, in conclusion, LRAM and RRAM care about increasing or decreasing. Does LRAM and RRAM care about concavity? No. But trapezoid does not care about increasing or decreasing. Trapezoid cares about concavity. Cool or not cool? All right, we're almost done. Okay, don't worry. We'll get out of here. I'll let you guys go in a little bit. I was thinking about not doing this question because this is from an AP style question, but I think it's fair if we start talking already about it. We will talk about it all next week about contextual questions, but we're almost there. We're at the epitome. Let's read it. We're only going to do letter A, and then we'll go to the next stuff. All right. Example 4. A car travels on a straight track during the time interval 0 to 60 seconds. The car's velocity v, measured in feet per second, and acceleration a, measured in feet per section, are continuous functions. The table shows selected values of these functions. Using appropriate units, explain the meaning of integral from 30 to 60 of absolute value of v of t dt in terms of the car's motion. So let's do that first. Integral 30 to 60 absolute value of v of t dt. Remember that this just means area under the curve. I go to the 30. I'm going to put an absolute value on the 14. Absolute value on the 10. I guess the 0 doesn't need an absolute value, and the 10 doesn't need an absolute value, but I'm putting them there. Let's think about what it means to find area under this curve. Remember, these are positive numbers because it's the absolute value, right? Feet per second times second. What will that give me? This is velocity. I'm finding area under the curve. Feet per second times second. No. First, start with telling me the units. Feet per second times second. No. Feet per second times second. Just feet. So this is going to tell me, no, not the position. No. Its feet is not speed. The distance that we traveled from t equals 30 to t equals 60. Okay, time out. Real fast. Remember when we started talking about area under the curve? You have a train that goes 50 miles an hour. So here's 50 mph for 2 hours. If I find area under this rectangle, 50 miles per hour times 2 hours, that's going to be 100 miles. So the area under that curve just tells you the distance traveled. Do we see that, guys? We're just rookies, but it's the distance traveled. So here it is. So this means distance traveled in feet from t equals 30 seconds to t equals 60 seconds. You could also set it different. It's the distance traveled in feet on the interval t equals 30 to 60 seconds. As long as you say it correctly, you're good. Cool? All right, here we go. Integral from 30 to 60 of v of t dt equals, all I'm doing is trapezoidal, guys, because they told me to. It says right here, approximate 30 to 60 v of t dt using a trapezoidal approximation with how many subintervals? 3, determined by the table. So go here. Look, your delta x's are different. Here's my first one. That's your first one. Here's your second one. Here's your third one. Do you guys see? So here we go. Base 1, 14 plus 10 times the delta x, which is, all I did was my formula, guys. Base 1 plus base 2 times height divided by 2. Are we okay? Plus, here we go with the next one. 10 plus 0 times what? Times what? What's my height? Oh, the second one. 15. The delta x is your height, guys. Divided by 2. Plus, open parentheses, 0 plus 10, close it, times 10 divided by 2. Now, it's too early to be playing games about exams, but since we have our first mock exam tomorrow, I'll tell you, and I shouldn't be saying it, but I am. You can leave it like this, and that will be full credit. If you're prone to making accidents, by the time we take mock exam 3, I'll see everything. I will tell you whether you should leave it alone or not, like individually. I want you to be courageous and to give an answer. But for now, that right there, just put the units, whatever that is in feet, that's your answer. Does that make sense, guys? Okay. Are we okay? What's up, Kyle? Because those are my y values. So if I were to plot this, remember those are absolute values, right? If I were to plot this, I'm going to say here's 30, here's 14 points, here's 35, and the next one is 10 points. And then look, that's my trapezoid. Because the way it looks, base 1, base 2, or B0, B1, it looks like this. It's because it looks like this, right? So as long as my trapezoids look like this, your vertical displacement is your base. So it's always going to be the y values. Always. You got it? Got it? Get it? Good. Okay, I'll stop. All right, for the reasons of trying to be fast, we're going to go ahead and skip B and C. We can actually do letter C. I think that's I shouldn't say the answer. I was about to say it. Let's keep going. So this is what you're going to be doing today, guys. This is from Delta. So selected values of fx is shown in the table below. What is the midpoint? Most of them are all trapezoids, but I do ask for some of these. There's going to be a few of them. Not many, like 3 or 4. Riemann sum approximation using 4 subintervals. Okay, so if I'm using 4 subintervals, here's how you find your delta x. Delta x equals, for this one, upper minus lower divided by, I want 4 of them. What's 20 minus 4? So 16 divided by 4. So my delta x is 4. All I'm doing is width times height. They're just rectangles. So here's my first rectangle. Delta x is 4. Here's my first one. That's n equals 1. Here's my second one. N equals 2. Here's my third one. N equals 3. Here's my fourth one. N equals 4. All I'm doing is width times height, guys. Width, 4. Height. What number do I use? These are my heights. 14, 20, or 33. Which one do I use? And one MRAM, midpoint. Which one am I using? The 20, because the 20 is the 6 is the middle between 4 and 8, so I'm using the 20. Do you guys see that? 4 times 20 plus 4 again times, what am I using? Which number? Yeah, which is? Not 33. Which one? 37. That's the middle between 8 and 12, because that's the width of my rectangle. Plus 4 times, what am I using? 42.5. Plus 4 times, which am I using? 37. Now, I'm not going to insult your intelligence. I think you guys can know how to use a calculator. You're going to need a calculator for some of these. It's going to say not round to the nearest thousands. So we're going to skip. Is that okay? All right, this one. Using 5 subintervals as indicated by the table. So these are not equal delta x's, and they want me to do a right Riemann sum. So here it is. My first one, n equals 1. My second one, n equals 2. The third one, n equals 3. Fourth, and fifth. Do you see how they're dictated? All right, all I'm doing is width times height. 1, that's the width. The difference between 1 and 0. Am I using the 11 or am I using the 9? Right Riemann. 9. Plus, what's the difference between 1 and 2? 1, and I got to use which one? The 9 or the 5? What's the difference between 5 and 2? I don't know, not 7. Difference. 3. And which one am I using? 15. What's the difference between 9 and 5? 4. Which one am I using? 15 or 22? And then the last one, what's the difference between 11 and 9? And which one am I using? And then, this, I'm sure you guys can just... All right. Last one, and then we'll call it a day. And I'll do the visual, because I know you guys want to see the visual. Let f be the function defined by 2ln of x. Do you guys know how that looks? Where 1 is right there. That's my 0. And I'm going to exaggerate it. I'm going to say here's 7. It says if 3 subintervals of equal length are used, what is the value of a right Riemann sum? All right, here we go. Delta x equals 7 minus 1 divided by how many rectangles? So each one is going to be, all right, here we go. Let's see, 1, 2, 3, 4, 5. All right, I think right there is good enough. 3, 5. All right, here we go. And I'm doing RAM. That's what it says, right? Right Riemann. Right Riemann sum. Right Riemann sum. Right Riemann sum. Are we still okay? All I'm doing is delta x times height, guys. 2 times, how do I find my height? I don't know, chop. 2 ln of 3. There's your height. Plus 2 times 2 ln of 5. plus 2 times 2 ln of 7. There's easier ways. There's shortcuts. You can type this into the calculator and use your calculator features, but there it is. And then it says approximate it. You're going to approximate it to the third thousandth place. Tell me, Kyle, what's going on? How do we feel, guys? Does all that make sense? All right, we're done. We got 40 minutes, 45 minutes. You can go upstairs if you want. It's probably better because it's quiet up there. And we're done.